Hello, my name is Shane Dunn. This is my presentation for my BIO-520 class, I believe, action potential for cardiac cell. If you're one of my students, please watch this video if it's helpful for you. If not, it's my master's class, so you can ignore it. Okay. So to recap on action potential, because GCU really doesn't cover action potential more in the first half of anatomy, so some of you guys still may be confused with some concepts, so let's recap some things. Potassium is the king on the inside of the cell. I usually say this by saying king. K means potassium, IN means inside. What this means is potassium is going to be found inside of cells. Sodium is going to be found on the outside of cells. Depolarization means being more positive. Repolarization means being more negative. So since potassium is found inside of cells, it wants to rush out of cells. And since sodium is found outside of cells, it wants to rush inside of cells. Oops, sorry about that. I'm going to keep this pen going. Or it did not work. I also are going to mention calcium is a new thing we're going to see for action potential for the heart. And calcium is going to act just like sodium. It's going to be found on the outside of cells. It's going to want to rush inside. It also is going to be the main thing is sodium and calcium are going to be things that cause depolarization. And potassium is the main thing that's going to cause repolarization to occur. Okay, so the phases of cardiac action potential. So there are 5 phases. We're going to start with phase 4. This is a diastolic phase or the resting phase. This by like the heart, the diastolic phase is where the heart is relaxing and filling up with blood. This is where the heart muscle relaxes. This is maintained by the sodium potassium pump. Once it gets enough signals, it's going to go to phase 0, which is our main depolarization phase. Sodium channels are going to open up. Sodium's going to come rushing in. And once we hit phase 1, we're going to have inactivation of the sodium channels. And we're going to have opening up of potassium channels, which means we're going to start going down, repolarizing a little bit. However, we have this phase 2 here that's not seen in a lot of our muscle contractions or neuron action potentials. This is the plateau phase. Potassium channels open up more, but so do calcium channels. And these are two are going to compete a little bit, and it's going to cause the graph to plateau for a bit. But eventually, we're going to hit phase 3, which is rapid repolarization. Calcium channels are going to close, and lots of potassium channels open up, which then leads to phase 4 again. So if that didn't make any sense, let's draw it out. I always think it's better to draw out action potential graphs besides just saying phase 4, phase 0, 1, 2, 3. Let's leave our axes. Over here, we have our millivolts, our energy, and over here we have our time. The numbers we're going to need to worry about is -90 for our resting and about -70 for our threshold. So we're going to start off getting kind of low, a slight increase. Once you hit -70, it's going to go really high up. And then this is where things get weird. It'll make sense in a little bit. Plateau, and then a decrease. There you go. So let's break this down. So first off, we have our phase 4. This is our resting phase with a sodium potassium pump. If you don't know the sodium potassium pump, remember 2K for a year, so 2020. But that 2K just means for every 2 potassium, 3 sodium is resetted. Which that means is 2 potassium is put into the cell, 3 potassium is put into the cell, 2 potassium into the cell, 3 sodium out of the cell. So, yep. Once it receives the signal, we'll talk about a little bit, it's going to keep going up until it reaches phase 0. Here is phase 0. Phase 0 is going to cause a lot of sodium channels to open up, so sodium comes in. There also is a little bit of some calcium causing it to kind of go up pretty quickly. I did forget to mention that this increase right here, kind of the red, there is some sodium coming into the cell, causing it more positive to reach threshold. So line right there. Once you reach this all the way to the top right here, you reach phase 1. Here, sodium channels will close, and tons of potassium channels will open, which causes this kind of decrease right here. We then are going to have our phase 3, which is this plateau phase. And what's going on here is you have all those potassium channels opening, but you also have some calcium channels opening. And it kind of keeps it going for a little bit. Oops, phase 1, sorry, it's not phase 3. My bad, that is phase 2. I do apologize for that. There we go. Over here, finally, our phase 3, our repolarization phase. Continues going down, 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 down. And over here, calcium is going to stop flooding in, and tons and tons and tons of potassium channels open, causing a rapid repolarization. That is basically it in a nutshell. So let's talk about how this occurs and where does our heart cells get its signals from. So the heart is an automatic system, has autonomy, which means basically it makes its own signals. That's why the heart beats by itself, but you don't have to think about it. While it is influenced by parasympathetic and sympathetic hormones and such, it still beats on its own. And that is because of pacemaker cells. Pacemaker cells are mainly going to be, are mostly or almost all found in the sinoatrial node or the SA node. So they're going to fire by themselves. That signal is going to travel to the anteroreticular node or AV node, AV, SA node. Going to go all the way down this bundle of His, the Purkinje fibers, and hit what causes the sodium rush, which causes phase 0 to occur. So let's talk about the phases of a pacemaker cell. There's only 3 phases: phase 0, phase 4, phase 0, and phase 3. So you might be asking why it's not 1, 2, 3 or 0, 1, 2. It's because it follows the same setup. Phase 0 is going to be at rest up to threshold. That's phase 4. Phase 0 is depolarization. Phase 3 is repolarization. So the cool thing about pacemaker cells is this funny current. So let's draw it before I explain it. So it's the same setup. Draw the same graph. Millivolts over time. There we go. Our numbers we want to worry about is -60 and -40. So we see a kind of increase, and then we see a rapid increase, and then it goes down. So going all the way down, it kind of quickly goes back up. It quickly goes back up. And it quickly goes back up. There's a reason why I drew multiple of those, and you'll see a little bit. So let's label the phases. So phase 4 is also referred as the funny current. So like I said, pacemaker cells are autonomic, which means they happen automatically. So sodium is going to rush in. The reason why they're called a funny current is right here. This part is called the funny current. All these red parts right here is because normally when sodium channels open, it's because they're getting more positive. However, with pacemaker cells, sodium channels open when they get more negative. And that's kind of funny because it's the exact opposite. Hence why they're also commonly referred to as funny channels. They're also called pacemaker potential channels as well. So sodium rushes into a threshold, and then we go to phase 0. Phase 0, phase 0, phase 0, phase 0. So in phase 0, what comes rushing in is not sodium, but calcium comes rushing in. And since calcium is a larger molecule and there's not as much around the cell, it takes a bit longer to get all the way up for it to go up. So pacemaker cells are actually slower than axons, which is kind of good because we want nice, regular, slow beats. The heart can fill it with blood and then squeeze it all out. We don't want super quick, immediate heartbeats because it's ineffective. Once you get to the point, starting going down, that's when you reach phase 3. Calcium channels kind of turn off, and lots of potassium channels open up. Potassium rushes out of the cell, and it goes all the way back down. When it starts, once it goes back to around -60, funny current occurs. Sodium channels open, goes up again. Same thing, goes up again. As you can see, that's why pacemaker cells are autonomic. It's the repolarization that turns them on. So it's just constant going, and it's the same numbers every time, which makes it automatic. So here's my references, and that's all I have for you. Hopefully that was helpful. Thank you. Have a great day.